This is a Colpitts oscillator that we have already seen. Just provided the circuit. This is the same oscillator. Uh, you can. This is the oscillator stage. First transistor that is acting as an oscillator, and this is the buffer. Buffer it provides pulling and frequency stability of this oscillator. You can connect any other stages, and after this the final capacitor, the coupling from the emitter, it's an emitter follower stage where you can connect further stages beyond that. And this is the oscillator, and as you know, there are two capacitors that is connecting the base and the emitter. It's connecting the base and the emitter to the ground. So those two capacitors are seen here. These are the base to emitter and emitter to ground capacitor. And here you can also see the base resistor, which is providing the base voltage towards the uh, base of the transistor, or it provides the the action current for the transistor to function. And the next is it's a capacitor that couples the base to the tank circuit. This is the tank circuit. Tank circuit consists of the coil and the capacitor, and this is a variable capacitor that is connected to the tank circuit. It is also part of this tuning network. So the the value of this the resistor and the capacitor, I mean the inductor and the capacitor, determines the frequency of tuning, and the which frequency we are that we are tuned to is determined by this inductor and the capacitor. Here it is another capacitor that is a variable type of capacitor. It is connected in series to the hot end of the it's actually connected in parallel, but it is provided through a capacitor connected in series. So you can vary the capacitor. Here the the value can be changed by adjusting this capacitor, the shaft, and you can therefore you can change the frequency of oscillation here. And these two capacitor acts as the feedback network. It provides the correct feedback to the base. This is the feedback capacitor. This is another capacitor that moderates the how the feedback, the amount of feedback that is coming to the input, the base circuit of the oscillator. And this is the collector resistor, and this is the emitter resistor, and this is the coupling capacitor. This couples the radio frequency signal from this part, from the emitter side to the base of the next transistor. So this is the coupling capacitor. So this is the overall wiring connections. So we'll just connect the this is the frequency counter, and connecting to the output, the buffer output of this stage, and just connecting it to a power supply. And here you can see the frequency readout that is showing 6 megahertz, around 6 megahertz. I can change the value to 4 megahertz and up to 6 megahertz to around 1 megahertz change. 4.888 is the readout it is showing here. I can change the value to up to 6 megahertz. So that much I can vary using this capacitor. You can adjust, you can have more capacitance and it will read more, you can change more, the shift of frequency will be more. So this is a very easy oscillator that you can build, and I will describe more about this tank. The this is the inductor, and the capacitor. This is a styroflex capacitor. These are styroflex capacitor which has more frequency stability, and it is more Q is more, and the quality factor is more. And this is a you can also vary the slug. You can see the frequency changing. When I vary the slug, I can change the frequency. It has come up to 7 megahertz. So this is a slug tuned oscillator. So this is the basic information description regarding the oscillator. Okay, thank you.